All right, it's time for our next conic section. This one is an ellipse. So if we look at our double naped cone here, if we take a cross section that is on a diagonal-ish, but going through the entire cone, we get this shape right here, which if you ask someone, what's that shape? Well, doing a better job of tracing it. What is this shape right here? They might call it an oval, but we call it an ellipse, okay? So what is an ellipse? An ellipse is a set of all points P such that the sum of the distances between P and two distinct fixed points called the foci is constant. What a great definition, because that isn't confusing at all. So it's very similar, that was sarcasm. It's similar to how a circle is formed, obviously, because it looks like a circle that someone sat on, right? Oopsies, I sat on this circle and squashed it, okay? So every point that's on the ellipse, if you connect that to this focus and this focus, plural foci, okay? And imagine, this is going to be terrible. I should really take a video of this happening, but I didn't. If I take this point and start moving it, okay, the terrible infographic here. Okay. All right. So if I start moving this point here and those two distances that if you connect them to each foci, the sum is always going to be the same. Whew. And I could easily show you that using something else other than what I'm doing, but I'm going to keep babbling and erasing what I drew on this. Okay, so that's how an ellipse is formed. All right, so once again, also, focus, there's two of them instead of one of them. And if you look at this is kind of looking like right here, like this right here looks like a parabola facing to the right, and here's the focus inside of it. This is a parabola facing to the left, and there's a focus inside of it. Also, the closer and closer those foci get to each other, they're going to merge onto one point, and that'll be the center, and then it'll be a circle, right? So things that you need to know are some vocab here, okay? So an ellipse has two axes. It has a major axis, which is the longer axis. If the ellipse is horizontal, the major axis is going to be a horizontal line. Horizontal segment, I should say. And then it has a minor axis, which is the shorter axis, okay? The shorter axis on this one is this vertical line because it is a horizontal ellipse. Where those meet is the center, okay? Then you have two vertices, right, which is the plural of vertex. On a horizontal ellipse, that's to the right and to the left of the center. On a vertical ellipse, that'd be up and down from it. Then it also has two co-vertices, which are a shorter distance from the center. Okay. Then it has two foci. The foci are always on the major axis, so they're always by the vertices or by the center. Okay. Never by the co-vertices. Am I forgetting anything? Nope, I'm sure if I am, I'll remember later. Okay, so we have... Here is a horizontal ellipse because the major axis is longer horizontally. And then here is a vertical ellipse. If you want to look at it as Ernie and Bert, okay? All right, so we are going to write an equation of ellipse, okay? All right, so for a horizontal ellipse, it looks very similar to a circle. So let's pretend like we're writing an equation of a circle, which we already did. X minus h squared plus y minus k squared, right? Oh my gosh, it looks like a circle. Equals, and if it was an ellipse, it'd be equal to any radius squared. Or sorry, if it was a circle, it'd be equal to any radius squared, r squared, right? But this for an ellipse is always going to be equal to 1. And then also, these are going to be fractions here. The two things that are underneath this, we're going to call this a squared and this b squared. Now, all these variables are important, so we need to know what hk, a, and b are, okay? X and y is any point on the ellipse. So let's start with hk. Duh, that's the vertex, or sorry, the center. The center, okay? So hk is the center. And I accidentally called it a vertex, which I can't because an ellipse has vertices, all right? Now, what the heck is A? A is the distance from the vertex to the center, from the center to a vertex. So this distance right here is A. This distance right here is A. Okay, the distance from the center to a vertex. B is this distance from the center to a covertex. So this distance is B. This distance is also B. Okay, so that's how you're going to write the equation of an ellipse. And you're like, hey, what are these foci doing here? We'll get to those in a moment. Okay, now let's write the equation. Actually, nope, let's write the equation of a vertical ellipse. Looks very similar. In fact, I'm going to use my friend duplicate. Duplicate. Here we go. Okay, looks very, very similar. The only difference is a squared and b squared are switched. Okay, once again, the center, HK. A is the distance from the center to a vertex. A. B is the distance from the center to a covertex. B. So if these equations look that similar, how the heck do we tell the difference between the two, right? So look at this right here. What's bigger in this picture right here, A or B? A is bigger. So this will be bigger on a horizontal ellipse. Looking at this one, what's bigger in this picture, A or B? A is bigger. So this will be bigger on a vertical ellipse. So you can tell if it's vertical or horizontal by which denominator is bigger. If the first denominator is bigger, it's horizontal. If the second denominator is bigger, it's vertical. Okay? And mind you, x minus h squared has to be first and y minus k squared has to be second in order to use that rule, but I'm not going to be trying to trick you by switching them. Okay, so things that we need to know. HK is the center of the ellipse. Got it. A is the distance from the center to a vertex. We have that labeled already. B is the distance from the center to a covertex. And then C, which you're like, what? We're going to graph our foci too. C is the distance from the center to a focus. How do we find C? We use this equation. C squared equals A squared minus B squared. C squared equals A squared minus B squared. And then we'll solve for C by square rooting. We'll say square root plus or minus, square root plus or minus. And we'll end up getting C is equal to plus or minus the square root of A squared minus B squared. And we'll get that value. Now that could be a whole number where we count like, oh, it's plus or minus 2, right 2, left 2, or up 2, down 2. Or it could be like root 13. And then we have to estimate where that is. Okay, let's start off by just finding this information, finding all of it without graphing, and then we will graph it, okay? For each of the following, determine the center of the ellipse, the vertices, and the covertices. We also should talk about its orientation, meaning is it vertical or horizontal, okay? So that's what I have to do first, right? So here's our first ellipse, okay? We know it's an ellipse because it has an x squared and a y squared. If it was just an x squared or just a y squared, that's a parabola. But if you're like, wait a minute, why is it not a circle? Okay. It's not a circle because it's not x squared plus y squared equals, 17 squared. Okay. And we'll get into that more when it's in general form. It's in its standard form right now. Plus sign right here is also helping us out. If that was a minus, not an ellipse. Okay, so is this vertical or horizontal? So look at the denominators. This denominator is bigger, right? So that's our a squared. A squared. A squared is always the bigger number. This is b squared. And that means that this is a horizontal ellipse, okay? And I'm going to write that down because I will forget. Okay, it's horizontal. All right, so now I'm going to find the center. The center is HK. There's nothing being subtracted off of X, nothing being subtracted off of Y. So our center is 0, 0. All right, our vertices are A units from our center, so we need to know what A is. A is the square root of 64, which is 8. So that means since this is horizontal, we are going to go right 8 and left 8. So right 8 from 0, 0 is 8, 0. Left 8 from 0, 0 is negative 8, 0, which you could write plus or minus 8 comes 0. Our covertices are B units from our center, where B is 6. that means that we're going to go up and down since we already went left and right. So if I go up and down from 0, 0, I get 0, 6 and 0, negative 6, which once again you can write as 0 plus or minus 6. Lastly, we need our foci. We are going to use the equation c squared equals a squared minus b squared to get the c value. So we are going to do c squared is equal to 64 minus 36. C squared is equal to 64 minus 36. Do a little mental math there. That, and as I say that, I'm like, well, what is it? 28, right? Yes. Okay. Wow. Bad mental math. Ouch. Now I need to square root to solve for c. Square root plus or minus. Okay. That is not a perfect square, but I am going to simplify it. 4 goes in there 7 times. So this is 2 root 7. All right. So now I am going to say where my foci are. My foci are c units from my center. So since this is a horizontal ellipse, I am moving right and left from that x value. So from 0, I'm moving right 2 root 7 and left 2 root 7. So that is plus or minus 2 root 7, comma 0. Right? It's from 0, you moved right 2 root 7. From 0, you move left 2 root 7, but I don't need to write that 0 down. If this was a 8, then I would have to write 8 plus or minus 2 root 7, but it's not, so I won't. All right, here's the next one. Look at the denominators. It's an ellipse, x squared, y squared, plus sine equals 1. We got it, right? Okay, the second denominator is bigger, so this is a squared, this is b squared. This is a vertical ellipse. All right, my center, hk, is negative 7, 5. My vertices, since this is vertical, are up and down a units. So a is 5. So I'm going to move up and down 5 units from this center. So remember, up and down is from this value. So I'm going to have negative 7, up 5 is 10, negative 7, down 5 is 0. All right, now I'm going to get my covertices, which are 2 units from my center, because b squared is 4, so b is 2. So I'm moving left and right from that point. So left of negative 7, 2 units is negative 9, 5. Right is negative 5, 5. Foci are c units from my center, so let's find c using c squared is equal to a squared, which is 25, minus b squared, which is 4. C squared is equal to 21. Square root to solve. Root 21 is not simplifiable, so c is plus or minus root 21. All right, remember I'm moving vertically from my center, root 21 to the, root 21 up and root 21 down. From where? From this y value. So my x value stays the same, negative 7, and from the y value of 5, I'm moving up and down root 21. All right, lastly, hey, wait a minute, that looks like a circle. But no, it doesn't, because there's a 4 here and there's a 1 here. If there were 4s on both of those, I can divide everything by 4 and it'd be a circle. But guess what? That is not a 4 and a 4. So when I have an x squared and a y squared and there's addition separating them, it's either a circle or an ellipse. So what you have to do is you have to look at the coefficients on that x squared and y squared. This is a 4, this is a 1. If they're the same, it's a circle. If they're different, it's an ellipse. So I want to get this to look like an ellipse. So an ellipse, it's always equal to 1. So I'm going to divide everything by 36 to get it to look like an ellipse. So now I have x plus 2, quantity squared, over 36, plus, simplify this fraction. 4 goes in here once, 4 goes in here 9 times. Y minus 1 squared over 9 is equal to 1. All right, so now everything else is the same here. So we have, this is a squared because it's the bigger number. This is b squared, so this is a horizontal ellipse. I don't like how my z's are blending, but whatever. My vertex is negative 2, positive 1. My a value is 6. So I'm going to go left 6 and right 6 because it's horizontal. So left 6 is negative 8, 1. Right 6 is 4, 1. All right, co-vertices are B units from my center. B is 3. So I'm going to go up 3 and down 3. So that's -2, 4 is up 3. -2 down 3 from that is -2. Lastly, I need my foci. So I'm going to do C squared is equal to A squared, which is 36, minus B squared, which is 9. So I have C squared is equal to 27. I wish it was 25, but it's okay. Square root plus or minus, simplify that. So we have plus or minus, 9 goes in there 3 times, so 3 root 3. Since this is horizontal, I'm moving left and right from my center. So from that x value of -2, I'm moving left and right 3 root 3, and then not changing my y value. All right, so now let's go ahead and graph these, right? Let's try some graphing. All right, so let's go ahead and do all that information and then just graph it. That's what I'm going to do here. Okay, so my first off, orientation, right? This is bigger, so it is horizontal. And I'm just going to put an H for horizontal to remind myself. Center is 2, -3. A is 5. So I'm going to go right and left 5 from here. So that's 7, -3 is right 5. And left 5 is 2 minus 5 is -3. So -3, -3. And I can always, when I go to, graphing is nice because if I mess up, I'll notice because I'll be like, oh, that's not right, 5. All right, B value is 4. So I'm going to go up 4 and down 4. So 2, 1. And then down 4 is 2, -7. And then my foci, C squared is equal to A squared minus B squared. So C squared is equal to 9. Ooh, that's nice. Plus or minus. You finally got a beautiful answer. C is plus or minus 3. So this is horizontal. So I want to move right and left 3 from here. So I'm not going to put 2 plus or minus 3 because I can add 3 and subtract 3 from 2. So 2 plus 3 is 5. 2 minus 3 is -1. See that? Beautiful. All right, let's graph this and make sure it actually looks correct. And I could have got those as I go. So on the next one, that's what I'm going to do. I'm going to use the graph paper to get the answers. Yeah. 2, -3 is the vertex. Sorry, the center. Boo. 7, -3. Ooh, just right on there. -3, -3. That's gorgeous. 2, 1. 2, -7. Ooh, just fitting on there. I'm going to make this ellipse, right, so I can see that it's horizontal. I'm hoping if I hold for a second, I'll make it nice. Sorry to make that grimace, but I was hoping that it'd make it beautiful, and it didn't want to. One more time. No. Okay, I give up. I can give up. It's fine the way that it looks. You're gorgeous. And then my foci. My foci are at 5, -3. And -1, -3. Beautiful. Gosh. Okay. All right, let's try another one here. All right, so this one's not in standard form. How many more do we have left here? 1, 2 more. Okay. This one's not in standard form, so we have to get it in standard form. So once again, x squared and a y squared plus sign. Is it a circle? Is it an ellipse? Look at the coefficients. Different. It's an ellipse. So to get it to look like an ellipse, we are going to divide everything by 144. Simplify your fractions. 36 goes into itself once. 36 goes into 144 4 times. 4 goes into itself once. 4 goes into 144 36 times. This is 1. Okay, so we have x squared over 4 plus y squared over 36 is equal to 1. All right, so this is a vertical ellipse. A is 6, B is 2. Love that for myself. Okay, center, 0, 0. All right, I'm going to graph as I go this time, okay? I'll show you what I mean by this. 0, 0. All right, since this is a vertical ellipse, I am going to go up and down a unit. So I'm going to go up 6, down 6, and then write down the points. 0, 6, 0, -6, or 0 plus or minus 6. Co-vertices are 2 units from the center, so right 2 and left 2. 2, 0, and negative 2, 0, or plus or minus 2, 0. Foci are c units from the center, so I'm going to do c squared is equal to a squared minus b squared. C squared is equal to 32 square root plus or minus. Simplify that. 16 goes into 32 twice, so this is 4 root 2. Okay, so my foci, I need to graph this, right? 4 root 2, what the heck is that? Don't use that to estimate it. Use this to estimate it. Root 32 is more than root 25, right? It's more than root 25. It's less than root 36. This is 5. This is 6. So this is 5 point something. So I'm going to go, it's vertical, remember, up 5 point something, down 5 point something. I also have to make my ellipse, which I didn't do it yet. This one is going to probably be cuter than my last one. Yep. Because it knew it wasn't a circle when I was making it. It knew it was elliptical. And that's where the word elliptical, or the name of the machine elliptical, comes from, because you're making an ellipse with your legs, not a circle. Okay, all right, I also need to write down where are those located. I can't look at here and be like 5 point something, right, or 0, 5 point something. So remember, we're using our center as guidance. So our center is 0, 0, and we moved up and down from that, so we didn't move left or right at all. And then from 0, we moved up and down for root 2, which we don't need this 0 here. So we're just going to say 0, comma, plus or minus 4 root 2. Voila. Okay, last one. I don't know how I want to do this. Do I want to graph as I go, or do I want to get, yeah, I'm going to graph. This is what I'm going to do. Okay, so first off, my center is negative 2, negative 1. And I'm going to graph as I go is what I was trying to say. All right, now I need A and B. A is 8. A is 9. B is 8. So since 9 and 8 are so close to each other, like this is almost going to look like a circle. Because like if it was 8 and 8, it'd be a circle. It wouldn't be an ellipse, right? So keep that in mind. Also, this is vertical. All right. A is 9. It's vertical. So I'm going up and down 9 units from this, or you can actually just go count up 9, count 9 down, right? And graph your points and then graph your points. It's up to you, right? So I can either look at the point and say that's negative 2, 8 and negative 2, negative 10. Or I can say, all right, I didn't move left or right. Up 8 from this, or sorry, 9 from this is negative 2, 8. Down 9 from that is negative 2, negative 10. See what I'm saying? All right, B is 8. So I'm going to move right 8, left 8. So that is negative 10, negative 1. And 6, negative 1. And if I want to double check, saying right 8 is 6, left 8 is negative 10. It worked, yay. So now I'm going to connect these points, making this vertical ellipse, which doesn't look that vertical. It looks more like, oh God. It looks more circular than anything, so I'm kind of exaggerating the verticalness to it. Okay, that's beautiful. If not, okay. Lastly, I need my foci. Okay, so c squared is equal to a squared, which is 81, minus b squared, which is 64. C squared is equal to, all right, mental math, you're up. That is 6, 7. Ooh, 17. Don't ever say that again. Square root plus or minus. I was doing math in my head. All right, so root 17, which doesn't simplify, so I'm just going to leave it as root 17. From my center, I'm moving up and down, right? So negative 2 is staying the same. From negative 1, I'm moving up and down root 17. And now I actually have to graph those, okay? So I need to approximate root 17. It's a little bit more than root 16, so this is 4 point something. So from my center, since this is vertical, I'm moving up 1, 2, 3, 4, and a little more, and then down 1, 2, 3, 4, and a little more. Okay, that's it. All right, so that's graphing ellipses. Tomorrow we move on to writing equations.